Hello learners, welcome to Atya Studies. As of now, we got basic understanding on 1D array and 2D array programs, right? So from today, we will start solving actual lead code solutions. And one more thing to say is we must understand few algorithms as well. For example, we have linear search, binary search algorithm, and few sorting algorithms. I will explain them in upcoming sections. This is our future plan actually. So I hope you are following my channel. If not, please do subscribe my channel. Okay, without delay, let's start solving today's problem, which is diagonal sum of square matrix. So first of all, what is square matrix? Square matrix is nothing but a number of rows and number of columns must be same. Let's understand the requirement first. So here square matrix is nothing but 2 cross 2, 3 cross 2, 3, 4 cross 4, etc. Which means number of rows and number of columns must be equal. So before doing some of these diagonals, let's understand two types of matrix were there. One is even matrix and another is odd matrix. For example of even matrix are, you all know 2 cross 2 is even matrix, 4 cross 4 even matrix, 6 cross 6 is also a even matrix. Okay, and similarly odd matrix are 3 cross 3, 6 cross 6, etc. Okay, let's take even matrix first. 1, 2, 3, 4. This is even matrix. 5, 6, 7, 8, 9, 10, 11, 12. This is example of even matrix. Sum of diagonals are 1 plus 6. Sorry, here number of rows and number of columns were not equal. 13, 14, 15 and 16. Here let's see the sum of diagonals here. 1 plus 6 plus 11 plus 16. Okay, here diagonals, which means the cross multiplication of matrix. Cross addition of matrix. 1 plus 6 plus 11 plus 16. Here 4 plus 7 plus 10 and 13 plus 4 plus 7 plus 10 plus 13. So sum of this is of even matrix, even addition diagonal, right? Let's see for odd one. 1, 3, 5, 6, 7, 8, 9, 5, 6. See, we'll do sum over here. 1 plus 7 plus 6. Okay, this is of left diagonal. Right diagonals are 5 plus 7 plus 9. Okay, so if we do sum over here, 6 plus 1, 7 and 14. The sum of right diagonals are 9 plus 5, 14, 14 plus 6, 21. See here, we are adding 7 twice, right? 1 plus 7 plus 6, 5 plus 7 plus 9. So in odd matrix, we need to remove this 7. We need to subtract 7 from the whole addition. Okay, because we are adding 7 twice. So similarly, if after getting the sum here, means 4 plus 5, 35. We'll get some 35, right? But We are adding 7 twice here, so we need to subtract 7 here. Okay, this is our requirement. Actually, we have a square matrix. We need to do sum of diagonals of even matrix and odd matrix. In case it is an odd matrix, we need to remove the middle element here. This is the middle element of this whole matrix, right? We need to subtract this one. In the case of even matrix, there is no such element is matching here. 1 plus 6 plus 11 plus 16, 4 plus 7 plus 10 plus 13. So there is no extra element is adding. Okay, so this is a leet code program which we can solve right now. Here matrix diagonal sum. So there is a class and they have given one method over here, a diagonal sum, which is getting one mat array as a parameter. We need to return sum of this diagonal. Let's understand the input. Given a square matrix mat, return the sum of matrix diagonals. Okay, we need to return the sum of matrix diagonals. Only include the sum of all the elements. Okay, which includes all the elements on the primary diagonal and all the elements on the secondary diagonal, which means sum of primary elements in the sense left diagonal elements are primary elements, right diagonal elements are secondary elements. 1 plus 6 plus 11 plus 16, 4 plus 7 plus 10 plus 13. So this is the sum we require. Secondary diagonal that are not part of primary diagonal. Secondary elements, which means not part of primary element. So here primary elements 176, secondary element 5 plus 7 plus 9. But 7 is a part of primary element, so which we need to remove this element. This is the requirement. Input should be like this, output should be 8, which is sum of the diagonals. Let's understand. Here I am taking first n is equal to mat.length. I am saving the array length in one variable. Later I am taking sum is equal to 0. I have taken here one variable. We are calculating sum, right? So I was storing 0 as initial value. So here I am using only one for loop. Int I is equal to 0, I less than n, I plus plus. I need to add sum to mat, right, our array. Ith position and ith position plus, this is of left diagonal, okay, which means primary diagonal. Secondary diagonal value as so mat. And how can we get secondary diagonal over here? I'll explain this line in detail. Let's write code at the moment. Mat I, so row is same. When it comes to column, n minus I minus 1. What is it? I'll explain. After calculating sum, if n, whatever length is, which means the matrix, if it is an even, we need to simply return sum. No need of doing any subtraction here. We have an even matrix, right? Do diagonal sum and just simply return sum. If it is not an even, then we need to return what? Return sum, but deleting the middle element. How can we get middle element? The total length divided by 2. The total length divided by 2, which is the middle element. Let's run the program first. Yeah, our test cases are passed here. So what is this program? I'll explain you. See here, we got mat length and one variable is also stored here. See what are the indexes of this. Okay, here I'll write the indexes first. For let's take for even, one is placed at 0 comma 1 is placed at 0 comma 0th position. Okay, which means the row is also 0 and the column is also 0. And similarly 0 comma 1, which means 0 is row position, 1 is column position. 0 comma 2, 0 comma 3. So we have 4 rows, we have 4 columns at 0th position. 0, 1, 2, 3, 4. Okay. Similarly, let's understand 1. This is first row at 0th column. First row at first column. First row at second column. First row at third column. Second row at 0th column. Second row at first column. Second row at second column. Second row at third column. Similarly, third row at 0th column. Third row at first column. Third row at second column. Third row at third column. So let's understand the positions over here. Diagonal means primary diagonals are 0 comma 0 here. Okay, I'll write separately here 0 comma 0 plus 1 comma 1 1 comma 1 plus 2 comma 2 position value also I need to add, and 3 comma 3 position value I need to add. ठीक है, got it. 0 comma 0 1 comma 1 2 comma 2 3 comma 3 position values, which means the value, column value and row value are same here. Understand once carefully. Here the row value and column value is same. That's why I have taken here only one for loop. I'm just adding for primary elements. I'm just adding row value, column value must be same. Okay, so I got the primary elements. For secondary elements, I just need to, these are primary elements. Primary elements. Okay, secondary element positions are 0 comma 3. Understand? 0 comma 3, 1 comma 2, right? 1 comma 2, 2 comma 1, 2 comma 1, 3 comma 0. See here, these are the secondary elements. 0 comma 3, how I am writing here, right? Mat of, okay, ith position, row value is same. Okay, 0. When it comes to the column value is changing to n. What is n value? The length, right? 1 2 3 4, right? N value n minus 1, 4 minus 1 minus I value also 0. Initially, I am just talking regarding initially. So now what is the value I am getting here? Mat, initially it is 0. Okay, I value is 0. 4 minus 1 means 3. It will pick, let's understand here this value, mat, it will pick ith value, ith position is 0, row position is 0 and column position is, what is column position? 3. First it will pick 0 and 3 value. Okay, yeah, we need that only. Later I value is increased to 1, right? This is, I am calculating this for secondary elements. For primary elements we got an idea. So we just simply taking the I value and j value should be same, means row value column value should be same. That's why I just write here like I and I, because the column and row values are same here. For secondary elements only, I have just given the expression like n minus I minus 1. What is that expression? I'm just explaining here, which is in for loop, right? That's why I values increased one by one. So first it will add at a 0th third position element, which is let's take 4. Okay, 4 is this value. Now at mat position, I value is increased, right? I value becomes what? 1 now. And how we are writing expression here? I'll write here mat I plus mat. I'm just giving I, and here I'm just giving what? N minus I minus 1. N minus I minus 1. I'm just taking here n is equal to 4. Okay. So now n is equal to 4. I value is, it is, we have calculated here for I is equal to 0. I is equal to 0. 0 minus 0, and 4 minus 0 minus 1, which means 0th position we have calculated here. Here 4 minus, what is I value here now? I value is increased, right? It is of ith position 1. Now I value becomes what? Is equal to 1, right? So 4 minus 1 minus 1. So what is the value over here? Mat of I first position, and column value becomes 4 minus 2, which is 2. See, at first position row and column position 2. This is first position row and column position is become what? 2. So we are just taking diagonal, right? We have calculated 0 to 3, 1 comma 2 also. So 1 comma 2 value is what here? We just using 7. Okay, so the value here is 7. Now I value becomes 1. I value becomes 2. Now we need to calculate ith position is 2 and jth position is 4 minus I value is 2 minus 1, which means mat second position row and column must be 4 minus 3, that is 1, right? So it is second position, second row and column is 1. Second row column is 1. Yes, we are calculating this only. So which means the value is 4, 7, 10. Okay, we are calculating 10. Now I value becomes 3. Okay. So n value is 4, right? So 3 less than 4, the condition will get true. Now calculating I value is row position is 3, right? And what is the column position? Column position must be 4 minus 3 minus 1, which means third row and column value is 4 minus 4, that is 0. So it will pick third row and column is 0. So it will pick 13. Okay, I hope you understand the whole expression. I'm just adding sum plus this primary element and this secondary element. What will, if it is an even, we just simply return it. We have complexity when it will odd. We are just subtracting the middle element here, n by 2. N is what? 4, right? Here n by 2, we'll see for this here, right? So if it is in odd, matrix mat n by 2, n by 2. Why I am taking like this? Because matrix n by 2 is more, means 4 by 2, right? 4 by 2, it is of row position. 4 by 2, it is of column position, right? Which means I will get 2 of 2. So we got 0. We have taken here. Okay, I'll take the positions over here, 0 comma 0. Okay, 0 position comma first column, 0 position comma second column, first position comma first column, sorry, first position comma 0th column, first position comma first column, first position comma second column, first position comma, sorry, here row is second position comma 0th column, second position comma first column, second position comma second column. So here we got matrix 2 by 2. So sorry, in by 2, in by 2. If it is the length is, sorry, length is 3 only, right? Not 4 here, 3. 3 by 2, 3 by 2, we will get 1. First position matrix is it, we will get our middle position here. So that's it. I hope you understand this program. If you get any doubt, please do let me know. Comment me in the below the video. Thanks for watching the video till the end.